So let's start with the chapter aldehydes, ketones, and carboxylic acids for class 12 chemistry. So in this chapter, first we'll have a look at the preparation methods of aldehydes and ketones, both, then separately aldehydes, separately ketones. So first one, oxidation of alcohols. Okay, so RCH2OH, this is a primary alcohol. On mild oxidizing agents, okay, they give RCHO, that is aldehyde. Okay, so instead of moderate, it's only mild. Okay, yeah. Then coming to secondary alcohol, if I talk again, mild oxidizing agent, they give us ketones. Okay, and for example, mild oxidizing agents can be PCC and PDC. Coming to dehydrogenation of alcohols, it is suitable for volatile alcohols and is of industrial application. Okay, so this alcohol, again, the only change here is we are just replacing those mild oxidizing agents with copper at 300 degrees Celsius or silver at 300 degrees Celsius, only that much. Then coming to hydrocarbons, from hydrocarbons we can prepare it by ozonalysis. Okay, first step is ozonalysis. Means what? So we have an alkene over here, right? So what is an alkene? Alkene is when we have a double bond between two carbons. Okay, this is an alkene. So reacting this alkene with ozone, that is O3, in the presence of zinc dust and H2O, what will we get? See, wherever there is double bond, add each oxygen. Okay, for one carbon add oxygen, for one carbon add oxygen, and we have O3, right? So these two will share one oxygen. Okay, link all those three as we have linked it here, and these compound will break to give us two aldehydes, to form two aldehydes. Okay, they will break in this way as shown to give two aldehydes. So what are the compounds formed? CH3CHO, right, the first one, and CH2O. Or what is the CH2O? Actually it is HCHO, right, formaldehyde. Okay, now similarly, if we want to do it for ketones, how will we do? For ketones, here we have a double bond over here, right? As you can see, CH3, C double bond, CH2. Okay, again one more CH3 is attached to the middle carbon. So again reacting this with O3 as usual, and attaching one oxygen over here, attaching one oxygen over here. Okay, and a shared oxygen. Okay, so the things formed would be CH3, C double bond, or CH3 plus HCHO. So let's break this one over here. Yeah, so here again we'll have the same thing. We have a shared oxygen over here. Yeah, we have a shared oxygen like this, right? Oxygen atom, one is shared, one will be attached to this carbon, one more attached to this carbon. Okay, these two are linked. Then how will we divide it or make the compound? We will divide it this way and this way. Okay, so the first, this is my compound, again HCHO, as you can see, CH2O or HCHO this side. And the next compound formed is what? CH3CH3 attached to the carbon. Okay, CH3CH3 attached, and a double bonded oxygen, and a double bonded oxygen. Okay, yeah. So this was about ozonalysis. Then coming to from hydrocarbons itself, the second method is by hydration of alkynes. Okay, so till now here we saw alkenes. Now we have alkynes. Means what? Triple bonded carbons, right? So CH3 C triple bond CH. Okay, here what will happen when on the reaction of dilute H2SO4 and HgSO4? Okay, Hg is mercury. It will give us a CH3COH double bond CH2. So what is the change happening here? So the change happening here, as you can see, one hydrogen is getting added to this carbon, and this carbon we are getting, okay, OH is getting attached over here, okay, by breaking only one bond. Okay, so again this is what? Here we have an OH form, means what? Alcohol, right? All. And here we even have a double bond, means ene, right? Ene. So this is called enol form. Okay, so this is unstable, And so this enol form is changed to a ketone. How? By giving this hydrogen over here and breaking this bond. Okay, breaking this bond, and here we will get the double bond. Okay, yeah. Now similarly we have for ch triple bond ch. Okay, similarly we have, attach h over here, attach over here. This is again an enol form, and reversible reaction, this will give us an aldehyde. Okay, this will give us an aldehyde. Now the thing is that here which rule should we follow? So here the rule that has to be followed, okay, see what we have out of water. If we have, see, now, how did I attach this H and OH over here from water, right? H2O. Water only has two ions, right? It has H plus ion and it has OH minus ion, right? It has OH minus ion. H got stretched, yeah. So it has OH minus ion, right? So these two are there. So what will happen? Out of this Ca and Ch, which is the carbon with less number of hydrogens? Of course, this C. So my negative part will go to the carbon having less number of hydrogens. This is called Markovnikov's rule. Okay, so this is following my Markovnikov rule. Okay, we are following Markovnikov's rule here. Yeah. So coming to the next thing now, side chain chlorination and hydrolysis. Okay, so this is attached to this one. Yeah. Yeah, so with this we are done with the aldehydes wala part, aldehydes and ketones. These were the preparation of both aldehydes and ketones. Now coming to only preparation of aldehydes. First is Rosenmann's reduction. So these named reactions are of course super important. Rosenmann's reduction from acyl chloride or from acid chloride. Okay, so if I have benzene ring attached with C double bond OCl and react it with H2PDBaSO4, it will give me benzaldehyde, right? Similarly, RC double bond OCl H2 PDBaSO4, it will give us an aldehyde, right? RC double bond OH or RCHO. Second, from nitriles and esters, okay, RCN plus SnCl2 plus HCl, it will give us RCH double bond NH. Okay, and this on reaction with H3O plus, it will give us RCHO plus NH3, and this reaction is known as Stephan reduction. Okay, Stephan reduction. Why reduction? Because as you can see, to RCN we are just adding hydrogens, right? First I added a hydrogen to C, added hydrogen to N, right? It became RCH double bond NH, right? Again, reacting with H3O, what happens is this O goes to RCH, right? It completes RCHO, yeah, and those hydrogens go to NH. Then we have, yeah, this same reaction can be done with the help of directly Dibal H, which is diisobutyl aluminium hydride. It can also be written in this way on the arrow. Okay, and the second step is reacting with H2O directly gives us our CHO. Okay, now again ester, when we talk about ester, reacting it with Dibal H and second step H2O will give us an aldehyde. From hydrocarbons, if we talk about by oxidation of toluene, okay, this is benzene ring with CH3 is known as toluene. Okay, on reaction with CrO2Cl2, okay, CrO2Cl2. Okay, so this is a very important reagent over here, which is CrO2Cl2 or chromine chloride. Okay, that is chromine chloride on reaction with CS2 gives us this chromium complex. So here let's become very careful again. See what is happening. Here we have CH3, right? So the only thing is one H remains the same. Okay, instead of 2H, one, okay, we have 3H, right? One H remains the same. The other 2H are getting replaced by OCrOHCl2 twice. That is the only difference. And then reacting this with H3O plus, that is hydronium ion, will give us benzaldehyde. And this is a super important reaction known as ETARD reaction. Okay, yeah. Then coming to use of chromic oxide. Now what if I use chromic oxide instead of chromyl chloride? Okay, this toluene on reaction with chromic oxide and CH3CO twice O in presence of 273 to 283 Kelvin temperature will give me, see again, one H is like that only, the other two H are replaced by OCOCH3. Okay, OCOCH3 twice. Okay, and this on reaction with hydronium ion in presence of heat will give us benzaldehyde again. So here coming to this thing now, the side chain chlorination plus hydrolysis. So this is my toluene again, side chain chlorination. Okay, chlorination means adding chlorine, right? Cl2 I'll add, okay, in presence of sunlight. So what will happen? I'll get a benzyl chloride. Okay, instead of this CH3, again only two H are getting replaced, and this Cl2 will go and sit with carbon. So what will happen? Again, this reacting with H2O and 373 Kelvin, that is 100 degrees Celsius, will give us benzaldehyde. Okay, this is another important Gatterman-Koch reaction. Okay, simple benzene on reaction with carbon monoxide, HCl, anhydrous ClCl3, and CuCl will give us benzaldehyde. Okay, as simple as that. Next, coming to ketones. Preparation methods of ketones. Okay, yeah. So from acyl chlorides, if I talk about 2RMgX plus CdCl2, first we will create that. Okay, CdCl2. We will create that acyl chloride with us. See what was happening. This is RMgX, right? Grignard's reagent. CdCl2. Okay, cadmium chloride. Okay, so what will happen? This on reaction with RMgX will give us R2CD, that is dialkyl cadmium. Yeah, let me write it down. That is okay, of course, dialkyl, because two R are there, right? Dialkyl, and Cd is what? Cd is cadmium, right? It is cadmium. Yeah. So this is dialkyl cadmium plus 2MgXCl. So we are not related with 2MgXCl. We only need this dialkyl cadmium. Okay. So this acyl chloride. What is this acyl chloride? This is my acyl chloride. Okay. So this is my acyl chloride over here. Yeah. So it's some weird shape instead of circle. Yeah. So better I highlight it. Yeah. So we have this acyl chloride plus R2CD, that is our dialkyl cadmium. Okay, it will give us our ketonic group. Okay, which is what? As you can see, R dash C double bond O R plus CdCl2. We also got the thing which we gave previously, right? From nitrites, if we have the second method, okay, which is CH3 C triple bond N plus C6H5 MgBr, reacting this with an ether, what will happen? CH3 C, this triple bond gets divided. Double bond will go to NMgBr and a single bond will go to C6H5. Okay, now what is happening here? H3O plus, again reaction with hydronium ion, it will give us CH3 C double bond O C6H5. In short, this MgBr is vanished or replaced by oxygen. Okay, now this is what? Acetophenone. Okay, acetophenone, this is phenyl group, right? Then from benzene or substituted benzenes, in short, Friedel-Crafts acylation. Okay, so this is my acyl chloride, again Cl, right? So this is my acyl group, benzene plus, whether it be aromatic or alkyl. Okay, acyl group in presence of course, if it is Friedel-Crafts, anhydrous AlCl3 has to be there. Okay, it will give us this benzene ring with C double bond O, and here that respective aryl or alkyl group is present. Of course, so this is ketonic group, right? Yeah, so that's a ketonic group. So here we are done with the preparation methods of aldehydes and ketones. Now coming to the chemical properties of aldehydes and ketones. So firstly, this is a ketone, right? C double bond O group. Or let me say this is a carboxyl group, right? Because this group is present in ketone as well as aldehyde, right? So this carboxyl group on a reversible reaction with Cn minus, it forms tetrahedral intermediate, which is, see what is happening here. A carbon with Cn, this side is Cn and that side is O. Okay, thus double bond from here is divided into O minus and Cn. Okay, again this on reaction with H plus, we will get, as expected, H plus will go with O minus, right? So we will get cyanohydrin. Okay, as simple as that. This is a very easy reaction. Okay, yeah. Then we have reaction with NaHSO3. So here NaHSO3. Okay, we have again dividing it. We have first one OSO2H and ONA. Okay, why OSO2H? Because this SO3 is just written like that, OSO2H. Okay, so we are just taking one oxygen front. Then ONA. Okay, this on proton transfer, what will happen? Proton transfer means what? Transfer of hydrogen, right? So OSO2Na and down will be OH. Means what? Bisulfide addition compound. Now this is a bisulfide addition compound and is crystalline in nature. That's all. Then coming to the third one. Okay, coming to the third one, that is reaction with RMGX and secondly with H2O or acidification H plus, right? So what will happen? This RC double bond O group, okay, reaction with RMGX and then second step H2O or H plus, we'll get COHR plus MgOHX. Okay, then coming to, this is an aldehyde, right? RCHO, right? So when this aldehyde RCHO reacts with ROH, which is an alcohol or HCl gas, it will give us a hemiacetyl. Okay, it will give hemiacetyl, which means what? See, only replacement is this O. Okay, C is in double bond with O, right? So one bond will be OR, another bond will be OH. Okay, then again reacting with ROH and H plus, it will give OR on both the sides. That's all. And this is what? Acetyl plus H2O. Now coming to this R C double bond O R ketonic group again reacting with CH2OH and CH2OH in presence of HCl gas and dilute HCl, it will give us ethylene glycol ketyl. That is, this R will remain the same, only oxygen will get divided and this will be a symmetrical thing. Yeah, you can see this is a symmetrical thing, right? Up also we have OCH2, down also OCH2 plus H2O. Then coming to C double bond O, again a carbonyl group, we have NH2Z. Okay, where Z is what? Z can be any group like aryl, alkyl, OH, NH2, NHCO, NH2, and then C6H5NH, right? So there is a table given in NCRT that we can refer. Okay, so C, one bond will be OH, another bond will be NHZ. Okay, one H gone with O. Then again it will form C double bond NZ plus H2O. Okay. Now coming to reduction reactions when we come. Aldehydes on reducing agent on reaction with reducing agents gives primary alcohol. Ketones secondary alcohol. Reducing agent examples nickel, platinum or palladium or NaBH4 or LiAlH4. Second, Clemmensen reduction. Okay, C double bond O group. Okay, Zn, Hg and HCl, it will give us CH2 plus H2O. Wolff-Kishner reduction, again the same thing, C double bond O, only the change is NH2, NH2 and a removal of water. It will give us C double bond O, N, NH2. Okay, observation. Then this on reaction with KOH and ethylene glycol in presence of heat will give us CH2 plus N2. Okay, so the products of Wolff-Kishner and Clemmensen are both same. Only Wolff-Kishner is quite lengthy of two steps. Clemmensen is just one step. process. Then coming to oxidation, okay, this RCHO, which is an aldehyde, okay, it gets oxidized by Tollens reagent and Felling's solution. Okay, so now what is the tolerance reagent? It is 2Ag, okay, not 2 for AgNH3 twice plus. Okay, this AgNH3 twice plus is known as tolerance reagent. In presence of 3OH minus will give us RCO minus plus 2Ag plus 2H2O plus 4NH3. Now coming to Felling's solution, when I come to, okay, so here the after mixing of the finals Felling's solution, we get 2Cu 2 plus plus 5OH minus, which will give us RCO minus Cu2O plus 3H2O, where this Cu2O is a red brown precipitate. Okay, now what is the Felling solution? Felling solution consists of Felling A and Felling B, where Felling A is CuSO4 in aqueous form, Felling B is Rochelle's salt, which is aqueous sodium potassium tartarate. This is the formula, C4H4O6 KNA.4H2O. Okay, so one more reaction we have at the end, that is RC double bond O CH3 in on reaction with NaOX, giving RCOO Na plus CHX3. Okay, RCOO NaCHX3. Okay, yeah. Now coming to the most important reactions of aldol, crossed aldol, Cannizzaro, and crossed Cannizzaro. Now coming to aldol condensation. Now it is performed by the carboxyl carbonyl compounds. Okay, it is performed by the carbonyl compounds having at least one alpha hydrogen, performed by either aldehydes or ketones having at least one alpha hydrogen. Which means what? See, if I have, this is my carbon, right? This is my carbon with attached with CHO group, right? Carbon attached with CHO group. How many hydrogens does it have? It has 3, right? So this is my carbon attached with the CHO group. So this is my alpha carbon. Okay. And how many alpha hydrogens are there? 3 over here. So yes, it can perform aldol condensation. Right? Now in aldol, it will react with dilute NaOH. Okay, what will happen for dilute NaOH? It will have this form now, 3-hydroxybutanol, which means CH3, okay, CH2CHO, okay, and where CH is attached with OH. As you can see, I am taking 2 moles, right? So both of them together will form this compound, and on removal of water and heating, I'll get CH3CH double bond CHCHO, that is but 2 enol. Okay, this is aldol condensation product. But what is that aldol? Aldol is hydroxybutanol, 3-hydroxybutanol, right? And similarly for ketonic group, if I do, this is my ketone, right? As you can see, CH3 C double bond O CH3, again 2 moles I have taken in presence of BaOH twice. What will happen? The same thing, removal of water in presence of heat will give me 4 methyl pentene, 4 methyl pent 3 in 2-one, right? Pent 3 in 2-one. See, this is the first carbon, second carbon, third carbon, fourth carbon. Fourth carbon has methyl group, okay, and this whole carbon chain has 5, right? And where is the double bond? It is on first, second, third carbon. So pent 3 in on the second is the ketonic group, so 2-one. So what is my ketone over here? This is my ketone, the intermediate thing, which is 4-hydroxy, 4-methyl, pentane 2-one, which is ketone. Okay. Now coming to crossed aldol. Now here I took both aldehydes, right? 2 similar aldehydes. Here I took 2 similar ketones. What if I take 2 different aldehydes? Then I will get the aldol product of the first aldehyde. I will get the aldol product of the second aldehyde. And then I will get an aldol product where this is the first one, this is the second one, mixture. And I will get one more product wherein this is the first one and this is the second one, a mixture. Okay, so that's it with crossed aldol, wherein we react with first, of course, with NaOH, second with heat. Okay, as you can see, we get CH3, CH double bond, CHCHO. Okay, this is only the first one, aldol condensation. Okay, second, When we come to CH3, CH2, CH double bond, CH, CH2, CH3. So this is the aldol condensation product of the second one, right? Second reactant. Now this when I come to, as you can see, CH3, CH double bond, CHO, CH3. So here the first one is this, and the second one is taken as this. But here CH3, CH2, CH double bond CH, CHO means this is for first one and this is the second one over here, right? Similarly, taking for aryl halides, okay, sorry, for allyl aldehydes, aryl aldehydes, that is benzaldehyde over here. Benzaldehyde plus benzene ring with C double bond O CH3, that is a ketonic group, right? So on reaction in the presence of OH minus at 293 Kelvin, we have 1,3 diphenyl prop 2 enone, which is benzal acetophenone. Okay, so this is the product form. Coming to Canizaro's reaction, if there are no alpha hydrogen atoms, then what? Okay, so then we have Canizaro's reaction. So here we have H C double bond OH, right? And HC double bond OH, which is what? Formaldehyde, right? HCHO. So, on reaction with concentrated NaOH, for aldol we use dilute NaOH. For Canizaro, concentrated NaOH will give us CH3OH plus HCOONA. And similarly, if I take aryl aldehyde, similarly, okay, benzaldehyde, 2 moles again, it will give me one, as you can see, CHO2, it has become alcohol, aldehyde to alcoholic group, right? And the second one, we have COONA. As you can see, first one becomes the alcohol and the next one becomes the COONA group. Crossed Canizaro, if I say, for example, if I take CHCHO and a benzyl aldehyde, which is benzaldehyde, right? Or aryl aldehyde. Okay, then what happens? This will undergo oxidation to form HCOONA. Okay, HCOONA, and this benzaldehyde will undergo reduction to give benzyl benzene ring with CH2OH group. Okay, yeah. So with this, we are done with the preparation and chemical properties of aldehydes and ketones. Now coming to the final thing, that is carboxylic acid. Yeah. So coming to carboxylic acid preparation, first from primary alcohols and aldehydes. Okay, this is a primary alcohol on reaction with alkyl. Okay, alkaline KMNO4. Alkaline KMNO4. First step and second step, H3O plus hydronium ion, it will give us RCOH. Okay, which is carboxylic acid. Then we have one decanol. Here I am taking an example. Okay, which is one decanol. Okay, this is one decanol. Why decanol? 10 carbon atoms. You can count. This is the first one. Here I have 8 of them, right? CH2 8 times. 8 of them. So 1 plus 8, 9. Plus 1, 10. Okay. This on reaction with CrO3 and H2SO4, which is called Jones reagent. Super important reagent names. CrO3 and H2SO4. Jones reagent forms CH3, CH2 8 times, that remains the same, only CH2OH becomes COOH. Okay, then comes to the second method. Coming to the second method, from alkyl benzenes or toluene. For example, this is a toluene, right? This is an alkyl benzene called toluene, right? So this on reaction with KMNO4 and KOH in presence of heat will give COOK. Okay, on further hydronium ion reacting with hydronium ion gives us carboxylic acid. Then this reaction with this KMNO4, again KOH, same heat reaction will give COOK. Hydronium ion reaction will give COOH. Okay, as you see, any amount of carbon doesn't matter, we will get COOK and COOH only, right? Then we have nitriles and amides. Okay, so RCN is again a nitrile for us, right? Reaction with H plus or OH minus in presence of H2O gives us RC double bond O and H2, which is amide. right? This amide on reaction with H plus or OH minus in presence of heat will give us RCOOH, which is carboxylic acid. Then coming to from Grignard reagent, okay? So RMgX plus CO2, right? This is CO2, okay? In presence of dry ether will give R C double bond O, and this side single bond O minus Mgx plus. So this on reaction with hydronium ion H3O plus will give us again a carboxylic acid RCOOH. Then coming to from acyl halides and anhydrides. Okay, so this is my acyl halide. So what is happening over here? Reaction with water will directly give me RCOH plus Cl minus, and reaction with OH minus and water will give me RCO minus plus Cl minus. Again, further reaction with H3O plus will give me RCOOH. Now benzoic ethanoic anhydride C6H5CO Okay, on reaction with water will give me benzoic acid. Will give me benzoic acid, that is C6H5COOH plus CH3COOH, that is ethanoic acid. So from esters if I come, yeah, this is a benzene ring, okay, attached to COOC2H5, which is an ester, right? Together it's an ester. Okay, reversible reaction with H3O plus, which is known as acidic hydrolysis. This ester on acidic hydrolysis will give us benzoic acid, as we saw, right? And this, the byproduct is ethanol, right? Alcohol. So if I do basic hydrolysis, then what happens? If I have ethyl acetate or CH3COOC2H5 reaction with NaOH, which is basic hydrolysis, it will give me CH3COONA plus C2H5OH, which again on reaction with H3O plus I have to get CH3COOH. So this is a two-step process. If acidic hydrolysis, one step; basic hydrolysis, two step, because again we have to react with H3O plus in the second step. Now coming to the chemical properties, first is the cleavage of COH bond. Firstly, formation of anhydride. So this is ethanoic acid, okay? Two ethanoic acids, okay, just placed like a mirror image, as you can see. And on reaction with H plus and heat, or P2O5 and heat, will give us ethanoic anhydride. As you can see, these here water is removed again, H2O water is removed, only one oxygen left out, joined to both of the carbons. Esterification, RCOH plus R dash OH in presence of H plus, reversible reaction giving RCOO R dash plus H2O. Reactions with PCl5, PCl3, SOCl2. Okay, so RCOOH on reaction with SOCl2, okay, and PCl5 and PCl3. So first having a look at PCl5. So RCOCl plus POCl3 plus HCl are formed. Reaction with SOCl2, we get RCOCl again plus SO2 plus HCl. While 3 moles of RCOH reacting with PCl3, we get 3 moles of ROCl plus H3PO3. Okay, then coming to one more type of this same thing, cleavage of COH bond, is reaction with ammonia, right? I'll just zoom out a bit, right? So for reaction with ammonia, we have CH3COOH plus NH3, okay, reversible reaction, we will get CH3COO minus and NH4 plus. Okay, this on reaction with heat and removal of H2O, we get CH3CONH2, which is acetamide, okay, amide, right? Then here we have benzoic acid plus NH3 reversible reaction, we get this benzene ring with COONH4, which is ammonium benzoate. Again reacting with heat and removal of H2O, we get benzamide. Okay. Now coming to synthesis of phthalimide. This is a super important reaction again. Okay. That is the preparation or synthesis of phthalimide. So this is my benzene attached with two COOH groups reacting with NH3. It will give me COO minus NH4 plus, okay, on both the sides of these branches, right? And again, removal of 2H2O in presence of heat will give me, of course, amide groups, right? CONH2 and CONH2 on strong heating and removal of NH3. So removal of NH3 as in like this, okay, one we will remove from here and this we will remove like this. So what is left with us? We are remaining with this benzene group. Again, COO don't change, okay, CO they don't change, only left group is NH is bonded to both the carbons. So this is my phthalimide, okay. So this is again a super important reaction. Now coming to the substitution reactions, halogenation, okay, RCH2COOH, okay, on reaction firstly with X2 and presence of red phosphorus, okay, and second is H2O, we get RCHCOOH, where CH is bonded with a halogen. The only work the halogen did was replacing a hydrogen. Okay, the X replaced one hydrogen. That's it. Okay, this is alpha halocarboxylic acid, and this process of halogenation is nothing else but Helmholtz-Zielinski reaction. Super important. Then coming to ring substitution reaction. Okay, again we have benzene with COOH, that is benzoic acid, reacting with concentrated HNO3 and concentrated H2SO4, giving us a meta-directing product, right? Meta-nitrobenzoic acid, right? And similarly, if I react with Br2 and FeBr3 as well, we again have a meta-directing product, right? So this is the reaction, okay. This is also Friedel Crafts reaction. So then coming to acidity, okay, acidity of carboxylic acids, it is directly proportional to the stability of anion, okay. So acidity, right, acidity is always directly proportional to minus M and minus I effect, okay. Basicity is ulta, okay. So now we will talk about acidity only. Acidity of carboxylic acids is directly proportional to the stability of anions, okay, which is directly proportional to minus M and minus I effect and inversely proportional to plus I and plus M effects, okay. If I talk about acidity, okay, least acidic are alcohols, okay, greater than alcohols phenols, okay, greater than phenols are carboxylic acids, but greater than carboxylic acids are the mineral acids, okay. Now if I say increasing order of acidity like this, then CF3 is greater than NO2, greater than CN, greater than fluorine, greater than chlorine, greater than bromine, greater than iodine, and then greater than the phenyl group or the benzene ring, okay. Now coming to involving COOH group, okay, chemical reactions involving COOH group, that is firstly reduction, okay, RCOOH group if we have, okay, reacting firstly with LiAlH4 in presence of ether, okay, and then second step H3O plus will give us alcohol RCH2OH, okay. Reduction, right, reducing agent, right, LiAlH4 in presence of ether or B2H6 can be used. NaBH4 does not reduce carboxylic groups. NaBH4, it does not reduce carboxylic groups, very very important. Now decarboxylation, RCOONA in presence of NaOH and CaO, that is calcium oxide, in presence of heat will give RH plus Na2CO3. Now what is this NaOH plus CaO? It is called soda lime, okay, which is a 3:1 ratio of NaOH and CaO, and this decarboxylation is nothing else but coal base electrolysis, okay. Yeah, so these were the chemical properties as well of carboxylic acids. And with this, we are done with this chapter. You can find the notes in the Telegram channel, whose link is attached in the description. Thank you.